Okay, I know we saw this in class, but we're going to officially take a look at graphs of exponential functions. Okay, so we're not talking linear, we're talking exponential now. And so there are these curves. Okay, you look at this graph right here. The y values are moving higher, 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 okay, away from the x-axis. So here's the x-axis, and the y values are getting higher, okay? So let's say that I have, I don't know, I have 5 books at home, okay? And every day I get to double that. I get to double that and double that, and so I'm going to get more and more and more books, okay? The domain, okay, the set of x values, I'm going to say is all reals. All reals. You can plug in any x number that you want. You could say 3 days or 4 days or 5 days. Okay, and the range are the y numbers. So domain is x and range is y. And so for the y values are going to be greater than 0. Remember, it's never going to touch 0, and they're just going to get bigger, bigger, bigger. Okay, the growth rate will be more than 1. Okay, more than 1. If you're going to grow, you have to double or you have to triple. Okay, and so what you're going to have is y equals a and then 2 to the x power, or y equals a times 3 to the x power. Okay, so the growth rate right there is the number inside. Now, if you look at the other side, the y values are moving towards the x-axis. Okay, the y values are getting smaller and smaller and smaller and smaller. But remember, never 0. It's just getting closer and closer. Okay, the domain. So what are the x numbers? Okay, you can plug in all reals. You can plug in any number you want on the x equation. I could say how many m&ms are left after 1 period, 2 periods, 3 periods, 4 periods. I could do this forever after 20 periods. You could do that forever. And then the range, okay, the y values are still more than 0. More than 0. You never get to 0. The y values, how many m&ms do I have? Less and less and less. But I never eat that last M&M. Okay. The equation here, the growth rate, will be a fraction. Okay, a fraction. So it's a number between 0 and 1. Okay. For example, maybe half, or maybe 1/3. So the equation will be y equals a, and then the number I'd put right here is 1/2 to the x power, or y equals a and then 1/3 to the x power. Okay, so if your base is a fraction, then you're going to have half, 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 half. It's going to go down. And if you have a number that's more than 1, like double, 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 it's going to grow. Okay, and so this is what exponential graphs look like. Let's classify the following as growth or decay. Okay, so you can think of this however you want. The graphs here have been shifted around to make them a little more fancy. And so I see as time's passing, I've got more, 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 more. Okay, so this is going to be growth. Okay, remember the domain, okay, is all reals. All reals. You could always plug in any number you want. But the range, okay, this graph doesn't go down, down, down forever. It seems like right here is the lowest it goes. And then it goes higher, higher, higher. So the y numbers are going to be more than, not 0. Okay, it used to be like this. Now they go as low as -1. But the graph is -1 and then higher. So you look at the y number, the smallest, draw a little dashed horizontal line to see how low it reaches. Okay. Oops, can't see that at all. Number 2. Okay, start on the left side of the graph paper and then ask yourself, what's happening? Is the graph going closer to the x-axis or farther away from the x-axis? Okay, since it's going farther and farther away from the x-axis, okay, look how far it's getting. This one is going to be growth. It's getting farther from the x-axis. Okay, domain is all reals. All reals, we're plugging in all real numbers. But what about the range? Okay, I'm going to draw the horizontal line here. Okay, the range for the graph is all here. There's no graph that way. All of the graph is under the number 1. So all of the y values are less than 1. Is that true? Zeros, negatives, is that where all the graph is? There's no y's at 4, 5, 6. You're right. Okay, let's do one more. Start on the left side of the graph paper and ask yourself what's happening to this graph as you drive towards the right. It looks like the graph is going down closer to the x-axis, closer, closer, but never, if you zoomed in, never touching, closer, closer, closer. So since it's getting closer to the x-axis, okay, that would be option 2. This is going to be exponential decay. Okay, domain is all reals. All reals. You could do this all day long. Any x number after 1, 2, 3, 4 hours. You're never going to eat the whole thing, so keep going forever. And how about the range? When I say range, you got to say y numbers. So let's look at the y numbers. Let's draw the horizontal dotted line. Is there any graph down there? No, the graph is always above 0. Y's are more than 0. You're never going to have 0 M&Ms. You might have a crumb, but you got to eat half of the crumb. Okay, we will practice this more. So just get it written down and we'll practice in class. How are we going to take a set of data values and make a graph? So we did this a little bit in class with the computer. So let's go ahead and do it by hand now. We're going to take -2, which is the x number, go 2 to the left, and go 1/2 up. Oh, that's so tiny. Okay, let's go -1, and then +1. Oh, that's a nice corner. 0 on the x, and then +2. Okay, is this linear? Oh, let's keep going. If we have 1 on the x-axis, 1, 4. Oh, that jumped up a lot. It jumped up more. So no, it's not making a straight line. 2 gives us 6, 7, 8. Okay, this is definitely exponential. Okay, I could see what's happening. So you draw a skinny little line. Try not to touch the x-axis. And then curvy, curvy, curvy. Whoa, and then it really starts to grow. Okay, remember how the money from the genie really grew? Okay, so this, since it's going up, up, up away from the x-axis, this is definitely exponential growth. Exponential growth. I could have looked over here and noticed that as I went 1, 2, 3, the numbers were getting bigger and bigger. Okay, let's do the next one. We're going to plot the points and see if it's growth or decay. So -2 is at 12. -1, 1 to the left, and then 6 up. 0 is at 1, 2, 3. 1 is at 3/2. 3/2 is 1.5. 2, 3/4 is like not even to the first box. Okay, I see what's happening. It's not a line. It's curvy, curvy, down, 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 curvy, curvy. Okay, but you're never going to eat all of it. I had 6 M&Ms, I ate half of them. I had 3 M&Ms, I ate half of them. Okay, I'm always going to eat half, but never all of them. So curvy, curvy. Try not to touch the x-axis, just get really close. So as time is passing, the points are getting closer and closer to the x-axis. So this one is exponential decay. Okay, think of those poor M&Ms, and decay is another way of saying goes away, aka I ate them and they were delicious. Okay, so if you have half, 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 then it's going to be decay. Okay, look what happened there. That's half. Half. Over here, this one was growth. I had 1 M&M. Oh, and somebody doubled it for me. That's times by 2. Look, they're doubling. They're doubling. I wish this would happen with my money. Double my money. Okay, when it's double, it's growth. All right, maybe when you look at equations here, you could tell me if it's growth or decay. Okay, so I'm noticing the equation right here. Look at this. I'm in a times by 2, times by 2, times by 2. That is double. Okay, and double means growth. I'm going to say exponential growth. Okay, the chart will also tell me that. So let's go ahead and type in our equation here. Let's go 3 times 2 to the power of, the first number I'm going to plug in is -2. Okay. And I get 0.75. And then the fastest way to type this would just be hit second enter. Go back here and change -2 to a -1. And that's 1.5. Okay. Second enter. Go up there and change -1 to 0. Let's delete that 1. Okay. Oh, that's a 3. Second enter. Let's change 0 to a 1. And that's 6. And for the last time, did you guys know I'm hitting second and then enter? And when you do that, it brings up the problem you just typed. And I can just make a quick adjustment and change the 1 to a 2. And that calculates to be a 12. Okay, let's see. Does it look like my numbers are doubling? Did it double? Did it double? Definitely. The numbers are doubling. This is going to be a growth problem. All right, let's graph it. -2, 2 to the left, 0.75. -1, 1.5. 0, and then 1, 2, 3. 1,6, 5, 6. Oh, look at that. It's starting to grow. 2, and then all the way up to 10, 11, 12. Okay. This is kind of like the pennies problem. At first, 1 penny, 2 pennies, 4 pennies, and then they really started growing, remember? Here is the exponential growth. We're going to go past the point, put an arrow, curve it down this way. Okay, put an arrow. Okay, try to get closer and closer and closer to the axis. I know it's tight, but you never cross down. You just get, smaller and smaller. This is definitely exponential growth. The values are moving farther away from the x-axis. Okay, exponential growth for sure. We got one more. There's a couple things I'm going to do. I'm going to study this equation. And I'm noticing that it keeps 1/4. 1/4. 1/4. That's going to be getting smaller, smaller. That's going to be exponential decay. When I say 1/4, I eat 1/4 of the M&Ms, and then I take 1/4 of them out, and I keep making it smaller, smaller. So we're going to go ahead and plug things here. Plug these values into the equation. So 2, I'll use the alpha y equals, get that fraction button. What am I doing? 2 times fraction 1/4. Okay. And then the power. The first power that we type in for x is -2. Okay, let's get our calculator. If you have calculator typing questions, make sure you ask me. So the first value is 32. Second enter, I'm going to change -2 to a -1. That's 8. Type in a 0. I should know this. If I put 0 right there, 1/4 to the 0 power becomes 1. 1 times 2. I think the answer is going to be 2. Yes, we should know that from our exponent chapter. Let's change 0 to a 1. The answer is a half. And finally, if you change it to a 2, I get 1/8. Let's look at this data here. 32 became an 8. They divided it by 4. That's 1/4. Did they divide this number by 4? Is that 1/4? Yes, look at that, 1/4. They all got divided by 4. That's definitely exponential decay. We're going to look at the graph and confirm that that's how it looks. So -2 gets 32. Well, that's way, way, way up off the graph paper. All right, let's do the next one. -1 gets 5, 6, 7, 8. 0 gets 1, 2. 1 gets half. 2 gets 1/8. Oh, it's getting super tiny. Okay, so the graphs started way up here. Half, or a fourth, and it's gonna curvy, and then draw it like this with an arrow. Okay, I'll put the arrow way up there. This is definitely, as time is passing, getting smaller, getting closer to the x-axis. This is definitely exponential decay. See you tomorrow.